a cutting progress of 1 and cutting progress max of 5, you would think 1 divided by 5 would equal 0.2. However, if we actually did that, over here we would actually get a 0. And the reason for that is because we are dividing two ints. Cutting progress is an int, cutting progress max is also an int. And if you divide an int by an int, then the end result will also be an int. Since you cannot define 0.2 in an int, the decimal gets cut down and you end up with just 0. So that would not be correct. In order to get the right value from this calculation, we need to make sure to convert one of these values onto a float. So that's really simple, we just cast one of them, so just cast this one to the float, just like that. Basically now this one will first be cast to a float, and then we're going to have a float divided by an int, and the end result will be a float. So if you ever do some math and you get some weird results, always make sure to check the type of your numbers. Okay, so here we are correctly firing the event, and then down here when adding our progress, let's do the same thing. Let's also fire on the event. So now we can go back into our progress bar UI, and over here let's listen to the event. And again, remember that if we're accessing an external reference, let's do that on start and not on awake. So cutting counter, listen to the on progress changed event. When that happens, let's just go bar image and set the fill amount to what we receive from the event, so the progress normalized. Okay, so that's really it. And also up here on start, let's initialize it as 0f, so the bar is nice and empty. Okay, so let's test. Back in the editor, let's just go back into the scenes, make sure the prefab has been saved, and let's hit on play. And right away, yep, we do see the bar. Yep, it is empty. Now pick up some cheese, drop it, and if I cut, and yep, there you go, added a little bit of progress, now a bit more. And there you go, there's our cheese. Okay, great, everything does work. Now let's add just one more tiny bonus thing. We can add some extra logic in order to hide this visual if the bar is either completely empty or completely full. That is actually pretty simple. Over here on the progress bar UI script, let's just make some basic show and hide functions. So private void show, and then we're going to have a private void hide. On these ones, just game object set active, this one set it to true, and this one set it to false. Now on start, we subscribe to the event, and then let's hide it, okay? Also here, it's very important, make sure you hide it after you listen to the event. If, for example, you called hide on awake, that would disable the game object and the start would never run, so it would never listen to the event. So if you ever set the game object as inactive, make sure you do it only after you're listening to whatever events you want. So we have this, that's great, and then when the progress changes, let's just do a basic test. So if e.progress normalized equals 0f, or if the progress normalized equals 1f, so if the bar is completely empty or completely full. If so, then let's hide it, and if not, then let's show it. Okay, that's it, let's test. Okay, and yep, by default starts off hidden. Let's pick up a tomato, go up there, and yep, still hidden. Now I cut, and there you go, there it is, cut again, and yep, there you go, it hides itself. Okay, great, so we've got a nice little visual. Let's do just one more final thing. Let's add a really nice animation. If we go inside the cutting counter, and we look at the cutting counter visual, over here, note how it already has an animator. Just like we did for the container counter, it's all very simple. So basically just has a cut parameter. When that happens, it just cuts the counter. So it just plays a simple animation. Since it's going to be pretty much exactly like the container counter, let's actually duplicate that script. So let's go down, find that script. So the container counter visual, let's duplicate this. So Control D. Let's rename this to the cutting counter visual. Okay, let's open. And over here, let's rename the script. So the cutting counter visual. Okay, great. Then for the parameter, let's rename this. Instead of open close, it's going to be called cut. And for the string, it's cut. Again, make sure you write it case sensitive. Make sure it's all correct. Then instead of having a container counter, we've got a cutting counter and a cutting counter. And finally, we just need to listen to the correct event. So technically, we could listen to the on progress changed. However, that one also gets fired over here when the cutting progress is 0. We don't want the cut animation to play when this happens. So let's just make another simple event. So a public event handler. Let's call this just on cut. Okay, and then down here when we have our cutting progress, so we cut and let's just invoke this event. Okay, that's it, super simple. So now on the cutting counter visual, let's go into the cutting counter and into the on cut event. Let's listen to this. And we're going to set the trigger exactly like this. So get rid of the container counter like this. Okay, there you go, a very simple script. So now here, back in the scene view, inside the container counter prefab, let's just go inside the visual. Let's attach the cutting counter visual. Just need to drag the cutting counter reference, and that's it. Let's exit the prefab, save it, and let's play. Okay, so now let's pick up a cabbage, go up there, drop it, and Alt Interact. And if there you go, we've got a nice little animation. All right, awesome. So I can drop things, I can cut them, and everything works perfectly. All right. So here we added a cutting progress to our cutting counter, and we also learned about yet another very useful Unity feature called world canvases. And at the same time, you might have also noticed that the canvas is looking at the camera in kind of a weird way, basically just pointing straight forward. This can sometimes make it difficult to see, so let's work on that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build a very simple but very useful script to make an object look straight at the camera with various options. Okay, so we previously made the cutting counter, and when I place something, yep, there's a nice progress bar. So now that this is working, let's do one more thing. Right now, look at how the bar is oriented. It's looking quite a bit slanted. That's because we have a perspective camera and it's looking from top down. Now, this is one of those things that is kind of personal preference, so maybe you don't like it just like this. But a lot of the times you want these world UI elements to face the camera just like a regular UI. One example of this problem is, for example, let me pick up the cutting counter, duplicate it, and let's put one down here. So rotate it upwards. Okay, let's put it on 4.5, 0, and -5. Now if I place something on there and I cut it, yep, look at that, the bar is now inverted. So let's make a simple script to solve this problem. Let's go into our scripts, create a new C# script, call it look at camera. Let's go onto the cutting counter prefab, let's open it up, go inside, on the progress bar, let's attach this script, so the look at camera. Okay, now let's open. So from here, let's use an interesting function. So let's use a private void late update. So not update, we have the late update. So if this is the first time you're hearing about this, like the name implies, this one is going to run after the regular update. So every single update and all the objects is going to run, and then all the late updates. So kind of like you've got awake and start, you have update and late update. Why this is useful specifically for this script is because for this element you really want this to run, the orienting logic, you want that to be done after whatever that object does in the update. In this case, this object will never move, so it's not really an issue. But for example, if you had some kind of moving vehicle with a world canvas on top, if you had that, you would want to set the world canvas location to look at the camera after the vehicle had moved. Otherwise, the canvas would not look perfect. So anyways, because that here we're doing on late update, and now we can just look straight at the camera. So we can just do transform.lookAt, and for the target, pass in the camera.main.transform. This function makes this transform look at another transform or another point, so this will make it look straight at the camera. Also, by the way, one quick note here. In some older tutorials, you might see people telling you not to use camera.main. The reason for that is because this field did not used to be cached, so every time you use this, it would cycle through every single game object in the scene until it found the main camera, so that was obviously really bad for performance. But nowadays, this field is now cached by default on the Unity backend, so you no longer need to cache it yourself. Accessing it directly just like this is now fine. Okay, so with this, let's test. Just make sure to save the prefab and let's hit on play. Let's go ahead, pick up a cabbage, put it up there, and if there you go, look at that, how it's looking straight at the camera. And for this one down here, same thing, cut it, and yep, there you go, both of them are looking straight at the camera. Okay, so that's great. You can also see exactly what it's doing if we try to move the camera. Again, we're using Cinemachine, so let's move the virtual camera. So over here, if I just play around with the position.x, look at that, look how, as I move the camera, yep, the objects are perfectly looking straight at the camera. So that's great, that's what we want. But also, you might notice one thing. Notice how the bars are actually inverted. Instead of going left to right, they're actually going right and left. Basically, this has to do with how the canvas by default assumes you are essentially going to look at it from behind instead of looking forward. So that is why when this game object is pointing straight at the camera, it's essentially inverted. So to solve this, actually quite simple. We basically just need to look in the exact opposite direction. But at the same time, sometimes we might want this exact behavior, having something look straight at the camera. Maybe we do want it to be inverted sometimes. So for that, let's make a nice complete script with all of our possible options. And for defining options, this is also an excellent way to learn about one more thing, which are C# enums. Enums are an enumeration, meaning a fixed set of options that you can have of something. So these are really useful when you have a fixed set of something, like for example, maybe a fixed number of options. So for example, up here, let's make it private, make it an enum, and let's call it mode. And then inside we can define all of our options. So let's say we have the regular look at and then look at inverted. Okay, so we have these two options in our enum. Now let's do a field of this type and expose it in the editor. So let's make a serialized field, private of type mode, and call it mode. Okay, let's save this and look what this looks like in the editor. And if we go inside the cutting counter and we look at the progress bar, you have a look at that, the mode shows up and it shows up as a really nice drop-down menu. So since we have a limited number of options, we've got a really nice menu where we can choose each one you want. So that's really awesome. That's one of the benefits of enums. They are really easy to use over here in the editor. Now back in the code here, let's decide which one to use. So on the late update, let's just do a switch on our mode. In case we are on the regular look at mode, then let's do exactly this. Let's simply look at it. In case we are on the look at inverted, for this we just want to look at the inverse position. So that's actually pretty easy. We just calculate the direction vector from the camera to this object. So a vector 3, call it dir from camera. And to get direction from the camera, we start from this object, so this transform.position, subtract the camera.main transform position. So this gives us the direction pointing from the camera. And then we just do transform.lookat. And instead of looking at the camera, let's look at the opposite position. So let's look at transform.position, so our current position, plus the direction from the camera. So we're going to be looking at the exact opposite point. Okay, so that's it. Let's test. And right now by default we have the regular look at. So let's just see it. Let's just place some objects. Okay, so right now it's still inverted. And something really nice is you can play around the enums even as the game is running. So let's go inside the cutting counter on the progress bar UI. For this one, let's swap from look at to look at inverted. And yep, look at that. That one is now looking perfectly. So this one is using look at and this one using look at inverted. Okay, great. It's all working. However, yet another thing that is all about personal preference. Note how the visual has a slight slant. This is due to how the visual is actually looking directly at the center of the camera. So you can really see it if I move the camera left and right, how it slants going left or going right. Again, this is all personal preference, it's just a visual, so maybe you do want this look. But let's see another method. So over here in our modes, let's add two more. Let's add camera forward and camera forward inverted. And then down here on our late update, let's add those. So the camera forward, and then we have the camera forward inverted. So for this one, for the camera forward, it's super simple. Let's just take this transform, use the forward, which again you can get or you can set it. And let's set it to the exact same one as the camera.main.transform.forward. And for the inverted, exactly the same thing, except instead of forward, we do minus forward. Okay, so let's see what this looks like. Okay, so here's the game with both counters. They're both currently using the look at mode. Now if I put a look at inverted, yep, that one goes left to right. Okay, great. Now if I put camera forward, yep, look at that. Now that one is perfectly straight. So even as I move the virtual camera left and right, look how that one is always perfectly facing the camera as if it was a regular UI element. And for the inverted, does the exact same thing, but inverted, so just like that. So that's it. These are the 4 modes. Again, these are all just visual elements, so pick whatever you prefer. For me, I'm going to be using this one, the camera.forward, so that everything is perfectly horizontal. So I'm just going to make sure to go inside the prefab, and on the prefab itself, modify it and set it as camera.forward. And now if I add a cheese there, yep, looks great. And if I add a cabbage here, and yep, it also looks right. Alright, so here we created a really nice, useful, generic script to make an object look straight at the camera in various ways. Note how this one has nothing to do with canvas or a progress bar or anything. It's really a generic script to look at the camera, so you can apply this to anything where you want it to look at the camera. Okay, so with that, the cutting counter is fully done. Now let's handle the trash counter in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, let's create the trash counter. This one is actually pretty simple. It's how we're going to drop something and just destroy it. Okay, so making the trash counter is going to be super easy. Once again, going to be another great practical example of the power of writing good clean code and having good organization in your project. So let's do the same thing that we've already done a bunch of times. So first of all, let's make the prefab variant. So let's right click on the base counter and create a brand new prefab variant. Call it the trash counter. Okay, let's go inside. And first of all, let's drag the visual. So find the visual prefab on the trash counter. Okay. Then let's duplicate it to make the selected. So let's rename this to selected. Let's add the selected counter visual. Let's add the visual inside of it. And on the visual, let's select the other material. So the counter selected. And finally on the selected, put it 1% bigger, 1.01. And start off with visual disabled. Okay. So that's the basics, just like we've already done so many times. Now let's make the script to run this. So let's right click, create a new C# script, call it the trash counter. And by the way, here we're already starting to have quite a bunch of scripts, so we should probably organize the scripts folder. So let's make a new folder. Let's call it counters. And let's make another one and call it scriptable objects. So on the counters, let's drag the base counter, clear counter, the container visual, the cutting visual. Then down here, the trash counter. Okay, let's drag them all onto the counters folder. And on the scriptable objects, let's put the cutting recipe and the kitchen object SO. Okay, now our folder is a bit more organized. So let's open up the trash counter. And over here, as usual, let's begin by extending the base counter. Okay, great. Then let's implement the regular interaction. So override the interact. And on this one, again, it's going to be super simple. We just check if the player is holding something, and if so, we destroy it. So just check if player.hasKitchen object. So if the player is holding something, go into the player, get the kitchen object the player is holding, and simply call destroy self. And that's it. It's this simple. Back in the editor, let's just attach a script. Let's make sure to drag the countertop point reference, and on the selected, drag the base counter reference. Okay, with this it should be working, so let's exit the scene, let's save the prefab, and let's drag it over here onto our scene. So let's drag the trash counter and put it maybe somewhere over here on the corner. So let's put it here on an X of 7, Y 0, and minus 3.5. Then let's also fill up these spots down here. So let's duplicate the clear counter, put one in there. Put another one in there. Let's put another one on the side, and for the trash counter, let's align it. So let's put it a bit more to the side, so on 7.5. Okay, great. And let's put it inside the counters, and now we can test. Okay, so let's see if we can interact with it. And yep, as I approach, yep, I do see it highlighted. Okay, great. And if I interact, obviously nothing happens since the player isn't holding anything. Now if I pick something up, let's say a tomato, and I don't want this tomato, so I want to trash it. And yep, there you go, it does get trashed. Alright, awesome. So this is literally it. Like I said, this is once again another excellent example of the power of writing good, clean code. This was super simple to implement because we have a really nice structure for how all of our counters work. Also because our interaction system is very well built. Also because the kitchen object system is very well made. It's because of all of that great, very clean code that we were able to implement a brand new counter in literally about 60 seconds. So once again, I hope that by following this course, you now understand why I'm always talking about the importance of writing good, clean code. It's exactly because of this. If you write your code correctly, it makes developing the game so much easier. At first, it might seem like the quick and dirty approach is faster, and usually in the beginning it is faster, but as soon as you add some complexity, the quick and dirty approach suddenly won't scale, whereas the well-built, clean code approach, this one will continue scaling very well. So here we have a fully functional trash bin so we can dispose of unwanted objects. Next, let's build a much more complex counter. Let's build a stove counter, which also requires building a really nice state machine. So let's do that in the next lecture. Hey again, another quick intermission. You're past the halfway point, so congrats again. By now, I really hope you've already learned a ton from the course. We've already covered lots of topics and built a ton of systems. I hope you've been following the website as you go through the lectures, and I hope reading the frequently asked questions has helped you in some way. Let me know in the comments how you've used the course website. Did you just read the FAQ, or did you also download some project files? Let me know, I'm curious to know. If you enjoy my teaching style, also look at my other courses after finishing this one, especially the turn-based strategy course. That one is an excellent follow-up for this one. Okay, there's still quite a bit more for us to build and learn, so let's continue in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build the stove counter. So we want to place some uncooked meat, then we wait for a bit for it to be cooked. However, if we wait too much, it's going to get burned. So let's implement that. Alright, so as usual, let's first begin by making our counter. So let's go inside the prefabs, the counters, let's right click on the base counter and create a new prefab variant. Call this the stove counter. And as usual, let's go inside of it. Let's find the visual. So inside the prefab visuals, the counters visuals, here is the stove counter. So let's drag it. Then let's duplicate this, rename this one the selected. Let's set the component, the selected counter visual. Then let's go inside on all of these. And by the way, this visual actually has some nice visuals that we're going to implement in a little bit, but for the selected, we really just want the static objects. So let's pick up all of these and let's select the counter select visual. Okay, nice and white. Then let's lock over here the parents so I can select all of these and drag all of them. Okay, great. And start off with all of them disabled. Okay, so that's the basic setup as usual. Just for the counterpoint, since this one has a nice little sub on top, let's lift it up by a little bit. So put it on a Y of 1.456. Okay, that looks pretty good. Just move it a little bit to the center. Okay, great. So now let's make our script. So let's go inside our scripts folder. We've got our counters. So in here, let's create a brand new C# script for the stove counter. Let's wait for it to compile. Let's attach the script and open. Okay, so here as usual, let's extend the base counter. Now, like I said, the goal for this one is to be able to cook our meat. And for that, it's going to be based on a timer. And to actually cook the meat, we're going to need to know which one is the uncooked meat type and which one is the cooked meat type. So for that, we really want the exact same logic that we did for the cutting action. We want some kind of place where we can store an input and output as well as a cook timer. So for that, let's actually just duplicate. So let's go inside our scriptable objects for the cutting recipe and let's duplicate this one. So Control D. And let's name this one the frying recipe SO. Okay, let's go inside. And over here, let's rename the object. Then we have an input, we have an output. And then instead of progress, let's have the frying timer max. And since this one is a timer instead of an int, let's make it a float. Okay, so that's it, pretty simple. Then back here in the editor, let's create our scriptable object. So let's go inside, let's make a nice folder. So a folder for the frying recipe SO. And inside, let's create one. So let's create a brand new frying recipe SO. For this one, let's call it meat patty uncooked into meat patty cooked. Then for the inputs, let's choose the meat patty uncooked. Now we have to make the other one. So let's go ahead and make that one. Let's duplicate this one, rename it to the meat patty cooked. And the object name, meat patty cooked. Let's select the different sprite. So this one is going to be the meat patty cooked, okay? And finally for the prefab, let's also make it. So for the meat patty cooked, let's go inside of it and also make sure to save the changes on our stove counter. So okay, now in here, let's get rid of this visual and use the other visual. So we want the meat patty cooked and let's make sure to drag the scriptable object. Okay, so it's all good here. Let's go back outside, save it. And finally over here on the meat patty cooked, let's just grab the prefab reference. So there you go, that one. Okay, so this one is working, and since we're here, let's actually make the other one right away. So let's make the meat patty burned. So the prefab, and let's also duplicate this to make the meat patty burned. Then on the text, let's rename this to burned. Let's choose the burned icon. And for the prefab, let's go into our meat patty burned and swap it out for the burned one. So there you go, nice and charred. And over here, swap it for the meat patty burned. Okay, let's save it. And finally down here, just make sure everything is correct. So the meat patty burned, just drag the scriptable object, the transform prefab, just like that. Okay, so all of our burned references, over here all of our cooked, and over here all of our uncooked. And again, when going through this process, always make sure that you match all the references on the scriptable objects, and also over here on the kitchen objects. So meat patty burned, yep, meat patty burned, for the uncooked, and for the cooked, there it is. Okay, everything is good, great. So now we can go back over here into our frying recipe SO, and for the output, let's output the meat patty cooked. And for the frying timer, let's put it on 3 seconds. Okay, so that's it, great. Now back in the code here on the stove counter, let's add an array of our frying recipes. So a serialized field, private, it's going to be an array of frying recipe SO, so frying recipe SO array, and call it frying recipe SO array. Okay, great. Then back here in the editor, let's go inside the stove counter. Let's make sure to drag that. So let's drag the meat patty from uncooked into cooked. Okay, let's also drag the counter top point. And finally, since we already made the script over here on the selected, we can also drag the selected. Okay, so our stove prefab should be working. Okay, let's go outside, make sure to save the prefab. Okay, now let's continue with the rest of the script. So let's make our override. So override the interact action. And when we interact with it, Let's validate dropping the object just like we did on the cutting counter. So let's go over here into our cutting counter script, and let's just copy pretty much the exact same thing. So let's copy all of this interact code. Let's go over here in the stove counter and just paste it. Now we also need to copy in our recipe. So over here on the cutting counter, let's copy paste those functions. So these functions go into the stove counter, and over here let's paste them. They're going to work pretty much the same thing. So we get an input, except instead of being a cutting recipe SO, we're going to have a frying recipe SO. So let's replace all the cutting recipe references with frying recipe reference. Then for the array, this one is the frying recipe SO array, and obviously let's rename these. So Control RR to rename all of them into frying recipe SO. Let's also rename the function. Instead of get cutting recipe SO, it's the frying recipe SO. Okay, so there's no more mentions of cutting over here. So let's use this function up here and up here. And just make sure to rename these the frying recipe SO. And down here, also same thing, so the frying recipe SO. Okay, so down here we have no more mentions of any cutting. Let's just go up here and solve all of these problems. So first we check if there's no kitchen object here, and if the player is carrying something, then we see if what the player is carrying matches any kind of frying recipe. If so, then the player is carrying something that can be fried. Then we set the parent, and for now let's not worry about the progress. So let's just get rid of all of this, just like this. Okay, so with this we should be able to drop, but only an uncooked meat. So back in the editor, let's just set up our scene. So let's drag a stove counter onto our scene. Let's put over there on X of 6, Y of 0, and 3.5. Alright, so let's test. Okay, so now if I pick up some cheese, I go up there and I drop it, and nope, doesn't work. Okay, great. But if I pick up some uncooked meat and I go and I drop it, and yep, that does work. Okay, great. So it works, and I can only drop the actual objects that match the recipe. Now, unlike the cutting counter, this one will not be based on a player-alt interaction. And actually over here, let's fix this minor issue. Basically, we added this debug.log error to the base interact because pretty much every single counter is going to implement this interact function, but not all counters are going to have the interact alternate action. So on this one, let's just do nothing. Let's not spawn an error. Okay, just a quick fix. So like I said, the stove counter, this one is going to be based on a simple timer. And for making some time-based logic, basically we have two approaches. One approach is to use a simple float timer, or you can also use a coroutine. Now, a lot of tutorials will teach you how to use a coroutine, and that's not necessarily a bad practice. It does work. It does achieve the desired result. So to do that, you would just make a function like fry timer. So you'd make a private, you have to return I in numerator, then call it something like handle fry timer. Then inside you can do a yield return and return a new wait 4 seconds. And to start this coroutine, you would do maybe on start, you would call start coroutine and start the handle fry timer. So this is one approach. This is definitely perfectly valid timer code. However, personally, I am not a fan of coroutines. It's not because of performance or anything. It's simply because I don't like the pattern that they force you to use. I don't like being forced to make a function that returns I enumerator. I don't like using yield return. I don't like having to use the start coroutine function. I don't like being forced to use this on a monobehavior object. Those are all requirements for making a coroutine work. And personally, I find those are way too many requirements that create a very strange pattern that I really don't like. So that's really the only reason. I don't like coroutines because I find this pattern to be quite a lot convoluted. So instead of coroutines, what I like to use are simple basic float timers. So just make a simple private void update. Then we just need to keep track of a certain timer. So for example, a simple private float frying timer. Then on the update, let's first check that we have an object, so it has a kitchen object. If we have a kitchen object, then let's increase the timer by time.time. By the way, here when working with a timer, you can increase or decrease. It's pretty arbitrary, both ways work. The obvious difference is only if you test if it's above the max or if it's under 0. In here for frying, it does make sense to start at 0 and then the frying timer max. So you do that, and if the frying timer, if it is bigger than the maximum, so let's get the frying recipe SO, let's get the frying recipe SO with input, so let's get this kitchen object and get the kitchen object SO. Okay, so we go into the frying recipe SO and we get the frying timer max. Okay, so if it's above the max, then this one has been fried. So here, let's just see what we did on the cutting counter. So let's get this kitchen object and tell it to destroy itself. And then let's go into the kitchen object class. In order to spawn another kitchen object, let's go into the frying recipe and spawn the output. And we're going to spawn it inside of this counter. Alright, so that's it. This should already be working. We don't have a visual yet, so let's add a debug log. So up here, just a debug.log on the frying timer. And up here, let's also just reset the timer. So frying timer, let's put it on 0f. And let's also do a debug.log and say fried. However, like this, you might already be guessing that we're going to have a bunch of bugs, but still, let's just test it just like this. Okay, so over here I can move around, I can pick up some uncooked meat, I can drop it there, and after a little bit, there you go, there's the timers. And yep, there you go, it did work. You can see the timer increased until 3, then it was fried, then it was reset, and then we've got a null reference exception. Basically, this is the exact same problem that we had on the cutting counter, where first we put an object like tomato, and that is indeed an input for a recipe. So we cut tomato into slices, but then the slices are not an input for any recipe. So over here we put some uncooked meat, so that's great, we fry it, which means we destroy the uncooked meat and we spawn the cooked meat. But then next time the cooked meat is not an input for anything, so obviously this one is going to return null. One thing we can do to sort of solve this problem, which is also going to be beneficial in terms of performance, is simply caching this field. So let's go up here, define a frying recipe SO, instead of constantly getting it on every single update, which might be a bit costly in terms of performance. Instead of this, let's just get it over here when the player drops something. So the player drops something and we assign the frying recipe SO, so we assign it, cache the value, and then do this. Okay, that should have fixed the null reference problem, but we still have a bunch more problems, but still, let's test it out. Okay, so here, let's pick up some meat, put it there, and let's look at the timer, and yep, there you go, everything is cooking, great, and yep, there you go, it finished, it cooked, and the timer was reset, and now it's finishing, it's cooking, and so on. So this is obviously another pretty serious problem. Basically, it's constantly frying the meat and spawning more and more objects. Instead of constantly spawning from the same recipe, what we want is for the stove to first fry the object, but then if the object is fried, then we want to burn it. So really, that means that we want the stove to have multiple states. Meaning that we're going to need to make a simple state machine. So let's do just that. Now, if you're a beginner, the concept of a state machine might seem daunting at first, but it's actually extremely simple, at least to make a very basic one. All we need is really just a bunch of states. So to define those states, let's go up here and make a simple enum. So let's make a private enum, call it state. And now let's put all the states for our state machine. Now for the stove, let's say we have idle when there's nothing on top. Then let's say we have a frying state for when the ingredient is actually being fried. Then we have fried for when the ingredient has already been cooked, but it's still getting some heat. And finally, if we leave it too long in that state, then everything ends up burned. Okay, so these are all of our states for our state machine. And now to make the actual state machine, it's actually quite simple. First of all, we just need to store the current state. So up here, make a private of type state and store the current state. And then on update, let's just do a switch on the current state. And now here, basically, we're going to do different logic depending on the state that we're at. So let's say if we're idle, we do something. Then if we are frying, we're going to do something else. Then if we are on the fried, also something else. And finally, if we are on burn, do something else. So here are all of our states. And the logic that we did down here, this is the frying logic. So let's actually just copy all of this. And let's paste it inside the frying logic. And for the state machine, we're only going to run any of these states if there's a kitchen object inside of it. So let's actually put that switch in there, just like this. Okay, so that's it. So when idle, we're not doing anything. And when frying, we're going to run our frying timer. We're going to fry the object. Let's also get rid of the log. We no longer need this. Then we destroy the current object and we spawn a brand new object. Now what we need is to handle over here the state field. We need to modify this when changing states. So first of all, let's handle the start. So let's make a private void start. And on start, let's begin with the state on state.idle. Okay, great. Then down here, when we interact, when the player drops something, that can be fried, over here, let's set the state and put it on state.frying. And over here, we should also probably reset the timer. So let's set the frying timer back into 0f. Okay, we set the timer and we reset the state. Finally, up here, let's not reset the timer since we're resetting the timer down there, since it makes more sense down there. So we do the frying timer, we end up frying, and then obviously we need to modify the state. So modify state and put it on state.fried. Okay, so that's the basics of our state machine. With this, everything should be working just the same as previously, except we're only going to fry once. So let's actually just put a log here, debug.log, object fried. And let's put one down here outside of the state machine. Just do a debug.log on the state. Okay, like this, let's test. Okay, so here we are. Let's pick up some meat and drop it on there. And there you go, it goes from idle directly into frying, and then it's fried. And yep, there you go, now it stays on fried. So it no longer goes on frying and it's no longer spawning any more objects. It went from frying into fried and yep, everything worked. All right, awesome. So we have the frying state working perfectly. Now let's handle the burning. In terms of logic, it's really going to be the exact same thing. We're going to have a frying timer. So let's copy this code and paste it down here. Now, technically we could reuse the exact same float timer, but that would be a bit confusing. So let's keep our code as clear as possible and really just make a different timer with a more descriptive name. So here a private float, call it the burning timer. Then let's initialize this timer. So when we go into the fried state, let's set the burning timer into 0. Then down here, let's use this burning timer. Okay, great. When timer is elapsed and the object is spawned, let's go into the burn state. And now obviously we need another recipe. So let's make another scriptable object. Back in the editor, let's find the frying recipe SO. Let's duplicate this. Call it the burning recipe SO. Then over here, let's modify the name. Instead of frying timer max, let's call it burning timer max. Okay, great. So now over here on the stove, let's use pretty much the exact same thing. And let's make over here private of burning recipe SO, the burning recipe SO. Then down here, we just need a function to get the burning recipe SO. So let's copy this and paste it over here. This one's going to return a burning recipe SO. So let's replace this and this. Rename this into burning recipe SO. We're going to need an array, and over here, let's just change the name. Instead of frying recipe SO, the burning recipe SO. And finally, let's just find a new array. So let's go all the way up here, make another array, an array of burning recipe SO. And this is the burning recipe SO array. And finally, if we go down here, let's use this array. Okay, that's it. So now let's use this function to set our burning recipe SO. So when we set it to fried, let's set the burning recipe SO. And let's get it with the input, and the input is going to be the object that is on here. So the kitchen object dot get the kitchen object SO. Okay, so we're initializing our fried state and setting up the burning recipe SO. And over here we use that one dot max, and we go into that one and use the output. So over there object fried, and over here object burned. All right, so that's pretty much it. We modified everything to say burning timer. Over here we are correctly initializing, so we go through the burning timer, through the burning recipe SO, which we are grabbing up here. Then we spawn the output on the burning recipe SO, and we go into state.burned. Okay, so all that's left is just filling in this array. So back in the editor, over here, let's make the object. So let's make a brand new folder for the burning recipe SO. And now inside, let's create a new burning recipe SO. Call this one the meat patty cooked into meat patty burned. And over here, let's set the input, so the meat patty cooked onto the meat patty burned. And for timer, let's make it take a bit longer to burn, so let's say 5 seconds. Okay, that's great. Let's just drag the reference, so let's go into the stove counter, and let's make sure to open up and go inside the prefab. And over here on the prefab, just drag the burning recipe. Okay, that's great. Let's go outside, save the prefab, and let's test. All right, so here we are. Let's pick up some meat, drop it on there, and look over there, it's frying, and after a bit, yep, it's fried. There you go. It spawned that one. And now if we wait for 5 seconds, it should go from frying into burn. And yep, there you go. That one is charred. Everything is burned. Everything is great. All right. Awesome. So everything worked as intended. With this, all of our logic is working. Now let's handle picking up objects from the stove. Now technically it's already working. So I can approach the stove and pick it up the object. And there you go. Drop it in there. So that does work. However, if we look over here in the log, the state machine is now in the wrong state. So over here, let's do a quick fix. Let's go down into the interact action. Okay, so here it is. So if there's no kitchen object, then the player places it. Okay, that's good. But if there is a kitchen object, so if there's something on the stove counter, when the player picks it up, let's also manually set the state and put the state back into idle, just like this. Okay, that's it. So let's test. Okay, so over here, let's pick up some meat, put it in there. It's cooking, and let's wait until it gets finished. Yep, there you go. It's done. Pick it up, and there you go, out. Now if I want, I can put another one, and yep, there you go, the logic is reset and everything is back to normal. Okay, great. So all of the logic is working perfectly. Now let's just get rid of our logs, so we don't need this. So let's get rid of that debug log, this one and this one. Okay, great. Everything is nice and clean. And now let's add some nice fun visuals. So if we go inside the stove counter, and over here is the visual, and I include these two prefabs inside the visual. So one of them, this one, the stove on visual, this one is just a glowing red square. Now again, there's a weird bug on this specific Unity version, so post-processing isn't showing over here on scene view. But if I leave it enabled and I go back outside, and now if we look in the game view, yep, there you go, there's a nice glowing red square. If you don't see it glowing, make sure you add the bloom post-processing effect. So if you missed something, you can go back into the post-processing lecture and make sure everything is set up correctly. So there's a nice glowing red square, and there's also a bunch of particles. So you can enable this one, press on restart, and there you go, just some nice particles just jumping up. This was made with the Unity particle system. So for example, on the hierarchy, you can right click, go up here into effects, and you can create a particle system. So that's what this is. It has a particle system. And over here, you can see all of the various settings. For these particles, they just jump up and fall down. So for jumping up, that is the emission. You can actually see a visual over there of the cone. That is the spawning cone, which you can find over here on the shape. So in the shape, it has the shape of a cone. Then you can see the radius thickness, and so on. So that is from where the objects are being spawned. Then up here, you can see the lifetime of each object. So each particle is going to last for 0.7 seconds. You can also see the speed, so that's the speed at which they come from there. The start size, that's how big they are on start. And note how the particles are spawning, jumping up and falling down. So that falling down is over here the gravity modifier. If you put it at 0, then they just keep going up. And if you put it at 2, yep, they go up and they fall down. Next down here on the emission, this is how many are being spawned. So if I put this on 200, there you go, tons and tons of particles. Next is over here the size over lifetime. So this one has just a basic curve. So they start off on full size, and over the x-axis, this one is the lifetime. So as the particle goes from the beginning until the end of their life, they basically go down on size. So that is why they become quite a bit smaller. Also, by the way, this one down here, this one is called an animation curve. This is another really useful Unity feature. I have a dedicated video on animation curves. And finally, down here, just have the renderer. So it's just using some basic particles. So we can inspect the material, it's included in the assets. And there you go, it's just using the default particle material, just with the alpha on half, and that's pretty much it. So as you can see, just a very basic, very simple particle system. Now all we really want to do is just, for both of these, we want to enable or disable them depending on if the stove is on or not. So let's make a script to handle the visuals. So let's go down and create a brand new C# script. Let's call it the stove counter visual. Then let's go into the stove counter visual and let's attach the script. So here it is, attach it and open. Right, so now here we just need references to those two objects. So as usual, let's make a basic serialized field. Let's make it of type game object for the stove on game object. And the other one is the particles game object. Okay, let's save. And back here in the editor, let's drag the references. So the stove on visual and the sizzling particles. Okay, great. So now all we really need to know is when to turn these on or off. And for that is really going to be based on the state over here on the stove counter. So if it is on the state frying or fried, then we want to show them. If it is on idle or burned, we want to hide them. But as usual, we don't want to mix the logic and the visuals directly. So let's do that through a really nice event. Let's make a public event. Let's use a standard event handler. Let's call it on state changed. And let's also include the state on the event args. So let's make a public class, call it on state changed event args, and let's expand event args. And then in here, let's just put a public state for our state. However, here we also have a really nice error. So this one is telling you there's inconsistent accessibility. Basically, that's because we made this one public. So any class, like for example our visual class, can indeed see this class. However, from outside, that class cannot see the private state. So that is why we have inconsistent accessibility. We cannot have something public which inside has something of a specific type which is private. So in order to make this work, we need to modify this state and make it public so that the other classes can see it. Okay, so that's great. Now let's just fire this event whenever the state changes. So over here, when you go into the frying state, let's go and invoke, and as usual, just this. And I actually forgot to add that, so let's go up here. Let's use the one with generics, so the on state changed event args. Okay, great. So then down here, when invoke the event, let's create of this type. and inside pass in the state equals this state. Okay, so this is all we need. So then down here, going to the burn state, let's fire the event, and down here frying, fire the event, and on idle, fry the event. All right, that's it. So we have all of our state logic. And now over here on the stove counter visual, obviously we need a reference to the counter, so let's add that. So a serialized field, private, make it of type stove counter for the stove counter. And then we can do, and as usual, for accessing external references, let's do it on start. Go into the stove counter, and let's listen to the on-state changed event. And over here, it's going to be very simple. We just want to show if it's on the state frying or fried, and if not, we don't want to show. So let's define a bool, call it show visual. And this one is going to true if the e.state equals the state.frying, or e.state equals the state.fried. So if it's either of these, then this is going to be true. If not, it's going to be false. So then let's just go into the stove on game object and call setActive and pass in this. And same thing for the other, for the particles game object. Okay, that's it, super simple. Let's just drag this reference. So over here inside the prefab, just drag the reference. Let's leave the prefab, save the changes, and let's hit on play. And all right, so it starts off disable. Okay, so there's no visual. Now if I pick up and I drop it, and there you go, a nice visual. So the glowing red hot and the particles, and now it's frying. And if I leave it until it burns, when it burns, then it's going to turn it off. And if there you go, it turns off. All right, awesome. So now if I pick it up, wait until it gets cooked. So it's cooked, pick it up, and there you go, turns it off. All right, awesome. We've got a really nice visual. All that's left is to have a proper visual progress bar. And with this, we actually have another interesting clean code question. Right now, the progress bar that we made over here on the cutting counter, that one is great, so we would like to reuse that. However, if we look over here on the progress bar UI, we can see this is only working with the specific type cutting counter. So by default, this will not work with a stove counter. So as usual, we have multiple approaches to solving this problem. One option would be to simply completely duplicate the script. Then we would make a completely different progress bar UI class that would work only with the stove counter. So that's one approach that would work. And that approach might be good if you want the progress bar to behave very, very differently. But over here, I want both of them to behave exactly the same. So instead of having some code duplication, we can write some good clean code, but doing exactly what we did with regards to the kitchen object parent. Meaning we can use a nice interface we can then implement on anything that has some kind of progress. So let's do exactly that. First of all, let's actually go inside the cutting counter. So let's go inside the prefab. And over here, we've got the progress bar, and this one is just a regular game object. But since we're going to reuse this, let's make this a proper prefab. So let's find over here all of our prefabs and just drag the progress bar UI inside the prefabs folder. Okay, great. So this is now a proper prefab. Now let's define our interface. So let's create a brand new C# script. As usual, interface starts with I, so let's call it I. And for this one, we wanted to represent anything that has progress. So let's just call it literally has progress. Personally, I like to use the word has to indicate that a certain object has certain behavior. So in this case, objects that implement this interface will have some kind of progress behavior. So now over here for the interface, let's first make it so this one does not extend modified behavior. Instead of a class, this one is an interface. Okay, great. So now for the functions that we're going to need, if we look in the progress bar and we look at the cutting counter references, we can see the only one is literally just this. So we just have to listen to the event, and then the rest of the progress bar works inside of it. So realign the interface is the only thing we need to define. So let's actually go inside the cutting counter. So here we have the onProgressChange event, and then we have this, so we can literally just copy this, go into the iHasProgress, and let's put exactly this. Okay, that's it. That is literally all we need. Now, if we wanted, we could also make a function to expose the progress amount, but since we included it over here on the event, then we really don't need it. Just this is enough. Now let's go over here on the progress bar UI script. And instead of working with the type cutting counter, instead let's work with a type that has iHasProgress. So let's rename this to hasProgress. And it's going to have the exact same event. The only difference is over here, instead of the event args being the one inside the cutting counter, is the one inside the iHasProgress. So let's make sure to change this, iHasProgress. Okay, so the signature matches. Let's just obviously rename this. So let's rename, instead of cutting counter, let's rename hasProgress onProgressChange. And that's pretty much it. We don't have any more errors. So everything over here is now working nicely with our interface. And back here in the editor, whilst we're still inside the cutting counter, sadly, interfaces do have one downside when it comes to Unity. If we look in the progress bar UI, down there we can see the progress bar UI, And previously we had the counter field exposed in the editor. However, now by changing into an interface, there we have the issue. The field does not show up here. Interfaces do not show up in the editor because Unity basically has no way of knowing that the interface will be implemented by some kind of game object. So sadly, this is the one thing that doesn't work very well with Unity. The solution that I normally do is actually pretty simple. Instead of exposing the interface, which does not work, instead let's just make this a regular private field. And then let's make a serialized field, and for this one let's make it of type GameObject, and let's call it hasProgressGameObject. Okay, so like this we have a regular serialized field with a regular GameObject. So if you look here, yep, we do have that field. So now we can indeed drag the cutting counter reference. And then over here in the code, in order to get the hasProgress, that is super simple. HasProgress, we just go into the hasProgressGameObject and get component of type iHasProgress. Okay, so that's it. Now our code does work. However, of course, one big potential issue with this is that over here we have a field of type GameObject, meaning that we have no guarantee that this field does have a component that implements the interface. So we cannot make sure that we drag the correct reference. We can drag any reference, doesn't have to have our progress interface. So in order to keep ourselves safe, let's add a nice safety warning. So over here, if hasProgress equals null. So if this one is null, that means that that game object does not have any progress interface. If so, let's do a debug.log error. And let's say the game object, and let's pass in this game object, does not have a component that implements iHasProgress. So this way, if we make a mistake, we will have a nice error message. Basically, this is the one workaround that you need to use since Unity does not support dragging references in the editor if they are interface references. Okay, so with that, everything is good. So all of our progress bar UI, this should all be working perfectly. We just need to go over here into our cutting counter script, and let's make it so that we implement our interface, so iHasProgress. And we got an error just because even though we did define that interface member, the onProgressChange, again, keep in mind that the types depend on not just their name, but where they're at. So this type that we have here is the one that we define here, which is not the same one that we have here. So even though they have the exact same name, because they are in different places, they are actually different types. So we need to make sure to use the type in the interface. So over here, let's just go into the iHasProgress and use that exact type and get rid of this one. Okay, so that's it. That's the change we need. And down here when firing, let's just fire with that type, and down here the same thing with that type. Okay, great. So like this, the cutting counter should still be working exactly the same as previously. Again, when refactoring any code, always do a quick test. So let's do that. Let's make sure to save our counter, save the prefab, go back outside, hit on play. Now let's pick up some cheese, put it there, cut, and there you go. The progress bar still does work. Okay, great. Now let's apply it to the stove, and that is actually going to be very simple. First, let's go inside the stove. So let's find the stove counter. Let's open it up, go inside the prefab. And over here, let's drag the progress bar UI prefab. So let's drag that. Then down here, we already have the hasProgressGameObject. So let's drag the stove counter, and that's it. There's nothing else we need to touch here. We just need to go over here into the stove counter, and as usual, let's implement the interface. So the iHasProgress. And now let's implement it pretty much just like we did on the cutting counter. So we can actually just copy this. So we just need to implement the event. So that's it. And now for firing the event, let's go down and see where we are modifying all of our timers. So let's go down to when the player drops something. So we do the onStateChange, and now let's invoke this event. So this, and for the progress bar, for the progress normalize, this one's very simple. So just frying timer divided by the frying recipe SO dot frying timer max. Okay, that's it. We are modifying the progress. Now let's go up here when we are in the frying state. And when we do, let's fire off the onProgressChange event. Okay, great. And finally down here, when we have the fried, over here, let's also fire, except obviously we have the burning timer and the burning timer max. And then just to make sure that the bar actually hides itself when we go into burned, let's also fire an event. This one doesn't have a timer, so let's just put it on 0F. Okay, that's really it. We don't need to touch the progress bar UI at all. Let's test this. Just make sure to save the prefab. Let's go back outside and hit on play. And right away, yep, the bar is indeed hidden. Now if I pick up some meat and I drop it, and there you go, got a really nice bar going up. And yep, going up on the burning state. And as it gets to the end, let's see if the bar hides. So it gets to the end. And yep, there you go, the bar does hide. All right, awesome. And if I pick up something, actually this was the one event that we forgot, so let's fix that. So let's just copy the one where we set the progress normalize to 0. And over here, if the player picks up something, let's set the progress back into 0. So here we are, let's pick up some meat, drop it on there. Okay, let's wait for it to be cooked. Okay, it's cooked now. Before it burns, pick it up, and there you go, the bar is gone. Alright, awesome. Okay, so here we have again another example of the power of writing good, clean code. We made a nice generic progress bar, and we very easily made it work with a completely different counter. Which of course would also work with literally anything that implements that interface. It doesn't have to be a counter. Now let me make one note here. Basically, I showed you how to make a generic progress bar and reuse it. But let's say you want to do something specific just for the stove. Well, one approach, like I mentioned, is to duplicate the code and make a progress bar that works only with the stove. But another approach is to simply add more elements on top. For example, during the polish stage, we're going to do exactly that. We're going to add an extra UI element that will show up to warn the player when the food is about to burn. So I just wanted to point that out how you can mix and match both of them. You can have both generic components coupled with specific components. But for now, our progress bar, everything is looking pretty good. So let's leave that burn warning just for the polish stage. Now the next very important thing we need is some plates, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create the plates counter. This one is just going to spawn some plates, which we can then pick up to grab some objects. Okay, so let's begin making the counter as usual. So let's go inside our prefabs, inside our counters, right click the base counter, make a new prefab variant, call it the plates counter. Let's go inside and let's drag the visual for the plates counter. Let's go into scene view so we can see it. Okay, let's duplicate this, make this the selected. Let's go inside and we can actually hide the circle sprite. We only need this one. So on this one, let's modify it for the counter selected. On the selected, let's make it just 1% bigger. And let's add the selected counter visual. Okay, then inside, obviously, drag the reference for the kitchen counter. Okay, that's our basic setup. Now let's make our script to run this. So let's create a brand new C# script for the plates counter. Let's attach the script to the plates counter and open. Okay, now here as usual, let's extend our base counter. And then first let's handle the spawn timer logic. So basically we want to spawn some plates every once amount of time. So let's store a simple float for the spawn plate timer. Then let's make a simple update on timer. Let's increase the spawn plate timer by time.delta_time. And then just check if it's above a certain maximum. So if it is above something, in this case we're going to have a fixed value. But still, like I mentioned at the very beginning of this course, let us not use magic numbers here. You should never use magic numbers. Instead, if you wanted to make it editable, you could also make it appear as a serialized field. But in my case, for the design that I'm going for, I'm perfectly content with having a fixed value. So just up here, pretty simple, the spawn plate timer max. And let's default it to 4F. And let's use it over here. Okay, great. So this is what we want. However, for spawning, it's actually going to be a bit tricky. The plate is supposed to be a kitchen object. The player should be able to carry the plate. And right now, for the design that we define, is that each kitchen object can only have one parent, and each parent can only have one object. But over here, we want to spawn multiple objects. Now let's quickly see what happens if we try spawning multiple as usual. So let's just go into the kitchen object, spawn a kitchen object, which means we need the plate SO. So let's do it up here. As usual, a serialized field, private, kitchen object SO for the plate kitchen object SO. So we're going to need to make this, and then we're just going to spawn this object on this. Okay, so this is going to throw an error, but still, let's see. Let's first create the object. Over here, let's go inside our scriptable objects, our kitchen objects. Let's create the brand new kitchen object. Call it just the plate. For the object name, this one is a plate. For the sprite, let's go with the plate sprite. And for the prefab, let's make it. So let's duplicate one of these, call it the plate. Let's go inside it. And obviously make sure to save the changes. Then over here, let's drag the plate visual, get rid of the tomato. And on the plate, let's make sure to assign the plate. And finally, let's exit this. Let's make sure to save it. And on the plate, let's drag the plate prefab. Okay, so we have the kitchen object SO. Now let's just go inside our plates counter. And over here, let's drag the reference. So the reference to the plate kitchen object. Let's also drag the reference to the counter top point. Then on the selected, drag the reference to our base counter. And finally start off with the selected disabled. Okay, so this should be working. Let's just add a plate counter over here onto our scene. So let's pick up a plates counter and put it somewhere in here over there on the side. So on an x of 7.5, then 0, and let's say on 0 maybe. Let's make sure we have space for